Today's lesson is going to start with precision and accuracy, but then we're moving on to dimensional analysis, and you'll understand the correlation in just a few minutes. So the first card is precision versus accuracy, and this is where you have to determine what is the difference between the two in mathematics and science. A lot of times in language arts, we kind of use the word interchangeably, but they're not really. Accuracy is actually how close a measured value is to the true value. Now, let's consider true value for a minute. It's the accepted value. For example, if you think about pi, one of the things for accuracy we say is the approximation of pi is 3.14. That's not the true value. Precision, though, is how close the measured values are to each other. So if you were trying to determine the circumference of a circle and you had the diameter and then you actually measured the circumference and your friend measured it, then most of you would find through a calculator how close to pi you actually would be. That is the precision. Here's an example for the back of the card. Notice that we have targets here. The target on the left has low accuracy. It's nowhere near the bullseye, but it is high precision because look how clustered they are together. In the middle, we have high accuracy, but we have low precision because they're not clustered. But on the third one, we have both high accuracy and high precision. Go ahead and complete your card. Now, another glossary card is degree of accuracy. Accuracy depends on the instrument you're measuring with, but as a general rule for accuracy, the degree of accuracy is half a unit each side of the unit of measure. Let me give you an example. If you were measuring in the ones on a number line, then any value between 6.5 and 7.5 would be measured as 7. But if you're measuring in the twos, then any value between 7 and 9 is measured as 8. Okay? So please notice that you could write this as 7 plus or minus 0.5. Okay? Or if you were measuring in the twos, you could write this as 8 plus or minus a value of 1. That would be how you would measure the accuracy. Now, it's time for your math journal. Go ahead and pull it out. And we're going to talk through this problem. Now, I know a lot of you could already figure this out, but this is the introduction to something called dimensional analysis. So if you'll just bear with me, I want you to go ahead and do the work with me. So please write down the key information about Farmer Vincent. With his barter system, 4 pigs equals 9 ducks, 1 goat equals 3 ducks, and 2 pigs equals 5 chickens. And the problem is, how many chickens could you trade for 6 goats? So, if you need to know how many chickens could you trade for 6 goats, what property, and remember we talked about properties Wednesday night, allows you to use unit dimensional analysis, to solve this problem? Have you got it? You're right, it's the identity property of multiplication. Now, Mrs. Rose, what do you mean, how does identity property of multiplication work? What are you talking about? Well, do you remember this back in 6th grade? Hopefully your teacher didn't accept that as an acceptable answer because the correct answer was 3/4. But do you remember how you got it? You went ahead and did the factorization, and then the identity property of multiplication says that any number can be multiplied or even divided by 1 or the equivalent of 1, and the quantity would stay the same. 2 divided by 2 just happens to be a big old fat 1, which is what gives you the 3/4. Now, it's the same thing if you have 5 gallons of gas and your car gets 8 miles for every 1 gallon. How many miles will you be able to go on that car? Well, hopefully your car doesn't get that bad of gas mileage, but notice here you have gallons and you have gallon, and gallon divided by gallon, A quantity divided by itself is 1. And so 5 times 8 is 40. And the word that's left in the denominator is miles. So Mrs. Rose, you could get 40 miles with 5 gallons of gas. So let's go back to Farmer Vincent. Okay? Step 1, if you're figuring this out, start by listing the given information at the left edge of the page and the unit of what we want to find at the right edge of the page. Okay? This is kind of like read for understanding. So you're given 6 goats and you want to find how many chickens. Step 2, multiply by the fraction based on the equivalency provided in the table. Let's see how that works. You go ahead and try and then pause and figure out if you have the same thing as I do. 6 goats over 1 times 3 ducks divided by 1 goat equals 18 ducks. Well, you've got ducks, that's great, but what do you need? You need chickens, that's right. Then multiply by another fraction, and you'll be able to find out how many pigs there are. Okay, goats divided by goats, ducks divided by ducks. 6 times 3 happens to be 18. 18 is divisible by 9 twice, so 2 times 4 is 8 pigs. Can you finish it from here? I'd like to see your answer when you come in tomorrow. Let's try another problem. On the way to diving in Salt Point, John frequently points out a chicken plucking plant. If exactly 2 chickens are to escape from the plant before being plucked, and chickens have on an average 512 feathers, how many feathers is the chicken plucking plant not plucking each year due to its daily escape rate? Oh my goodness. Well, what do you start with? You start with 2 chickens, right? And you want to end up with how many feathers? Okay, so look at the information, and what do you know about the chickens? Well, 1 chicken equals what? 512 feathers, that's right. Notice that chickens is in the numerator, so where do I want chickens to be if I want to use the multiplication property of identity? That's right, in the bottom. 1 chicken, by the way, the bottom is called the denominator, has 512 feathers. Oh, chickens divided by chickens, I'm good to go. But I need a feathers per year, correct? Well, ladies and gentlemen, what do I know? 2 chickens escape on 1 day. Oh, wait, Miss Rose, there are 365 days in 1 year. Day, days. So what do I have left? 2 times 512 times 365. The word that's left is feathers, divided by 1 year. Now, when you do problems like this, ladies and gentlemen, please, 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 please use a calculator. I know you know how to multiply, so use a calculator. And hopefully your final answer will be 373,760 feathers are lost every year. Hope you did really well. Okay, let's try one more. And this one is kind of silly. It's about chocolate chips and cookies and how to make kids goofy, okay? So do me a favor and pause it for just a minute and write down the most important information that you have. And we'll see if we match, okay? Welcome back. I have 47 chips for every one student, to be goofy. And my final answer is I want to know how many cookies I have to make. Well, let me see. I know that one cookie takes 29 chips. Now, if you want at this point, as you do this, you can go ahead and use that identity property of multiplication to make yourself a lot easier. So right now you have cookies, okay, per 29 students. Well, this isn't really going to help me, Miss Rose. Let me try something else. Okay. Let me see. Oh, wait, Miss Rose. I know that there are 18 students for every one class. Okay, so that's good, Mrs. Rose. I can go ahead now and say students, students. Okay, but I have more than one class, don't I? Yeah, I have 6 classes. All I need in my answer is the word cookies. If there's any other words, I can't use it. Oh, class, class. Great. So now, what do I have left in the numerator? 47 times 1 times 18 times 6 cookies divided by 29. Is that what you got? Great. Then my answer is 175.03448 cookies. Oh, silly Miss Rose. How can I have that many cookies? Ladies and gentlemen, this is the difference between precision and accuracy. This answer is very precise. The calculator told me so. But it's not very accurate because it's not the true measure. So, ladies and gentlemen, because this is food, this is approximately equal to, and what you need for a correct solution is 176 cookies. That is the correct solution because it is reasonable. Now, ladies and gentlemen, I'm giving you one more problem that I'd like you to write down, and I hope you can finish this out. I am not going to work this problem with you. I want you to write as much information as you can, get the answer, and then tomorrow when you come into class, talk to your partners to see if we have the same answer. Great start for dimensional analysis. See you tomorrow. Have a great green and gold night.